So welcome to this webinar on thermal loop solutions, a path to improve performance, sustainability and compliance in heat treatment and associated equipment. My name is Peter Sherwin and I lead business development for Watlow, focused on heat treatment and associated equipment. So typically chambers, furnaces and ovens. So this webinar links back to another webinar we held back in July 2021, looking at heat treatment tomorrow, and featured Doug Glenn from Heat Treat Today, Janusz from Ipsen, Dan Herring, the Heat Treat Doctor, and Andrew Bassett from ATP. Now, quite a bit has happened since that webinar. Urotherm was purchased by Watlow from Schneider Electric back in November last year, and now is a premier product brand of Watlow. And we've been reorganizing our teams globally to ultimately be able to provide more focus to vertical markets such as heat treatment. In the previous webinar, we did talk about a number of topics, including reshoring in US manufacturing, sustainability in vacuum heat treatment, changes in pyrometry standards, the rise of AI and machine learning, changes and developments in data acquisition through physical and virtual channels, the rise of electric vehicles and impact on heat treatment, and a future look at potential innovations such as virtual sensors and a focus on different energy sources and energy efficiency. As a follow-up to that webinar, we're going to focus on three areas in this webinar. The first is looking at vital manufacturing efficiency, upgrading crucial heat treatment with thermal loop technology. The second section looks at driving sustainability in heat treatment processes. And in the third, we will discuss adapting to evolving heat treatment compliance standards. Now, during the webinar, there will be a number of poll questions. Please take the opportunity to answer these. Hopefully, these insights will benefit everyone on the webinar. We should also, as I mentioned before, have time at the end of the presentation for some questions. We are monitoring the chat, so please type any questions in the chat area as we go through the webinar, and then we'll have some questions at the end. Just as some basics, this webinar will cover kind of the basic components of a thermal control loop, and we'll also highlight recent developments in thermal loop technology. So let's get into the detail of the webinar. Why is heat treatment such a crucial component of manufacturing industries? So as judged by the aerospace industry, heat treatment is a special process. So what do we mean by special? With many other manufacturing operations, you can judge a component's quality by visual inspection, measuring the size and shape post-machining operations. But with heat treatment, you want to achieve properties both at the surface and the subsurface. You cannot destructively test every component, but you need to assure quality as many components that are heat treated provide critical functions across our lives. And their correct functioning ensures safety across every industry you can imagine. So we employ sampling plans along with other techniques to ensure quality. For example, ensuring that you have approved process cycles, approved equipment, and approved personnel. Heat treatment is special and crucial. In Goldratt's seminal book, The Goal, he introduces the theory of constraints through the story of Alex Rogo, a plant manager who must improve his plant's performance or face closure. In this story, as in many manufacturing operations, heat treatment is assessed as a crucial but bottleneck process. And if we look at productivity in manufacturing as a whole over the past decades, you'll see that we've entered a plateau. We need to focus attention on the bottleneck processes and not just broad brush efficiency tactics over the entire factory. Putting some extra care and attention in bottleneck processes such as heat treatment will start to improve this overall product production position. In my journeys across the planet, I've seen a complete spectrum of heat treating equipment and operations, from dusty and very basic furnaces outside in desert conditions to fully automated clean room lights out facilities. And in between these two extremes lie the bulk of heat treating processes, typically semi-automatic control and a mix of discrete controls, PLCs, energy control, and data management solutions. Let's now look at how we can improve performance and efficiency in heat treatment by leveraging thermal loop technology. I will focus on electric equipment for this webinar, and these principles can be applied across production equipment, including autoclaves, ovens, furnaces, and also laboratory scale equipment, including test chambers. A modern thermal loop can be split into three distinct areas: the furnace or thermal chamber, the control panel, and then also the connectivity to the wider plant and operations, be it on-premise or remote. I'll be stepping through components on this image to describe current and potential thermal loop technology. Starting with the furnace, we have the heating source, often some form of electric resistance element. The material and design of the element is usually dictated by the temperatures required, the energy input, and furnace construction and atmosphere. Nickel chrome is often a good choice for a wide range of temperatures up to 900 degrees Celsius or 1650 degrees Fahrenheit, and other materials and alloys that can reach higher temperatures, including iron chrome aluminum, silicon carbide, and molybdenum disilicide. Some examples that are shown of typical heater types include immersion heaters for oil quench baths and industrial washing machines, duct heaters typically used in lower temperature tunnel type ovens and aluminum processes, as well as tubular elements common in tempering ovens and furnaces, multi-cell insertion heaters for thermal and heated presses, and finally ceramic fiber heaters for higher temperature furnaces. Let's move to thermocouples. So to accurately control the energy input into the process, we need to be able to precisely sense the temperature. Typically in heat treat furnaces, we use thermocouples to sense the temperature and provide this information to the control panel. The aerospace standards also illustrate how we can increase the number of sensors within a chamber to capture a more reliable picture of the entire work zone uniformity from batch to batch. So for example, using instrument type A to measure the load, temperature, control, as well as high and low positions from a prior to US. Thermal loop technology developed by Watlow for the semiconductor industry as an interesting development and further information about the energy in the process. It leverages the heating element as a sensor. This opens up possibilities of new designs of heating systems to ultimately improve temperature uniformity as well as the life of heating elements. It also starts to enable differential heating system control for distortion-prone components that could benefit from specific heat patterns when ramping to temperature. So we have the possibility of the heater element as a sensor, but how do we control the power to the heater? Let's move to the control panel. So mechanical contactors historically have been a common way to control the availability of electric power to the elements. But following several research papers by Watlow over the past couple of decades, we've been able to demonstrate the impact of this slow-acting power device on the life of elements. Fast-acting SCRs with phase angle firing certainly improve the situation, but they have introduced their own issues with creating noise disturbances on the electrical line and potentially impacting other sensitive equipment, and the potential to raise the required overall power to the process due to losses on the line. Advanced SCRs with hybrid firing methods have overcome the issues of typical SCRs by allowing the use of mixed firing modes to avoid overuse of phase angle firing. In conventional control, the thermocouple sensor is an input to the temperature controller, which converts millivolts to a temperature reading. Using PID principles, the controller is constantly looking at the PV, process variable, and comparing this to the desired set point. And depending on the difference between the two readings, it will call for more or less energy into the process. It will output a signal to the power controllers, let's say an SCR, to provide more or less energy into the system. At different temperatures, the behavior of the oven or furnace may differ, and so it's advantageous to take advantage of multiple PID sets that can be automatically triggered by temperature range. In modern PID controls, the auto-tune function can accurately aid setting these constants at different temperatures. By using Ethernet communications between the SCR and the controller, it is also possible to gather data related to the element health as well as energy use in the process. Specific SCRs that do this include the EPAC, the Aspire, and the ePower ranges. And just to note, development of the ATS solution for Watlow has also provided embedded power control and power control within the same platform. So I think now we're coming up to one of our first poll questions. So this is, do you use gas or electric ovens or furnaces? And so there's just a selection of 100% gas and then everything in between to 100% electric. So just give a few seconds for everyone to answer this poll. So we've got a few poll questions, so I'm going to go pretty quickly through these. So a few results are coming in. I'm going to now switch over. Interesting. So just under 10% with 100% gas, 30% with 100% electric, and then a mix in between. Okay, I appreciate that feedback. We have another poll directly after this one. So in electric furnaces, what type of power switching devices do you use? From contactors to SSRs to SCRs to hybrid type SCRs, and you can select all that apply. Okay, I just had some feedback that I need to give a bit more time for people to answer. We've already got sort of at least half of everyone that's answered this so far. Okay, so moving on. So interesting, still around 40% have contactors, then a mix of SSRs, SCRs, sort of the highest level, and only a few sort of hybrid type SCRs, sorry. Very interesting. Let's move on with the slideshow. So if we look at other components within the control panel, the high limit or over temperature device is used to protect the equipment from exceeding its normal operating temperature range. Historically, specific devices are used for this operation with their own temperature sensor. Updates to a number of Watlow and Eurotherm brand controllers have enabled combination control and over temperature solutions within the same physical box, with separate circuits and sensor inputs to meet FM requirements. I also want to pick up on one other element in the control panel, the data recorder. This is the memory of the system. And without an accurate memory, we can't prove the process was run as desired, and we don't have data to use to optimize the cycles. Historically, paper chart recorders with many circular charts were used particularly in North America. Digital data capture in a secure tamper-evident format is far superior to the paper option, with all the issues surrounding in-use of paper chart recorders, such as mechanical jams, pens running out, the cost of consumables, and constant changing of paper, as well as the time-consuming search for documents, post-process analysis, paper storage, and protection of paper documents. Today, driven by the standards, both aerospace and automotive mandate digital data. There has been a rapid move to digital, but this has not been without its issues. We seem to create a lot of digital data silos that now require additional manual effort needed to aid communication between these silos, as well as some current thinking or current solutions being cumbersome to use and requiring in-depth training. More modern systems have overcome this situation. The Nanodac, shortly the F4T, the 6000 series panel mount chart recorder, and the VersaDAC DIN rail version all now communicate with a modern data platform called Data Reviewer. The other benefit of the data recorder is its high accuracy physical inputs. Some companies are using this to their advantage, and instead of buying a PLC with expensive and currently long lead time precision I/O cards, they leverage the I/O in the data recorder and transmit the readings to the PLC across Ethernet-enabled industrial protocols like Modbus TCP or Ethernet IP. Not all data recorders are the same, and in order to take advantage of this, you need precision inputs. These are not always standard on all the products out there, and generally there will be a price difference for these cards. But these come as standard across many of the Eurotherm branded products, and we're currently enhancing some of these features in Watlow products as well. So we do have another poll question on, do you use paper charts or digital paperless chart recorders? And so we've got a section on paper, paper and digital, or all digital. Again, we'll give a few seconds for this to be answered. We've got about half the attendees that have answered so far, so we'll just give it a few more seconds. Okay. Interesting. So industry has moved on quite a bit. So only 5% with paper, sort of a mix, just paper alone, mixed with paper and digital, and kind of a significant level that are all digital now, 60%. Really interesting feedback. Okay. If we look at the design of the control panel itself now, there are potential areas for improvement. So some pioneering trends that Watlow have been able to provide include smaller panel doors to enable safe access to the low voltage areas of the panel. And then if we look at another slide, and more recently started utilizing systems thinking and a three-dimensional view of the panel. So we know when instruments get hot, they either don't perform or you have an impact on their overall life. It's pretty common in a heat treat department where the ambient air temperature is generally raised. Cooling of the cabinet is critical, and only a fraction of cabinets have some form of true air-conditioned cooling. All other panels typically have inexpensive fans shuttling heat around. So Watlow have developed standard panels that incorporate cooling airways in 3 dimensions, reducing the overall maximum heat buildup. We also have products in development that are being designed to aid this methodology of reducing overall cabinet temperatures. The final component is the ability to move data across the plant and for analysis on-premise and by expert support, either on-site or remote from the facility. Standard panels designed by Watlow now have been termed intelligent panels and include the ability to capture, analyze data, and also provide insights at a plant level, as well as enabling linkage to external experts. These can be service teams, OEMs, and also back to Watlow, where we have a team of Industry 4.0 experts and data scientists who provide consultative services to aid optimizing equipment and plant floor operations. We have capabilities using AI teamed with data scientists to examine in detail micro drifts within the process to ultimately aid throughput, quality, and energy performance. So we have another poll coming up. Okay. So this is a question about the use of Industry 4.0 technologies. Is it on your mind? Is it in planning? Are you already doing pilots, already installed? Maybe you have your entire factory is I4O connected. Okay, I think we'll go ahead and look at the results. Interesting. So just over a third, it's not really on the mind at the moment. 40% have it in planning, few, 10% in pilots, similar amount installed, and very few have got their entire factory I4O connected. So I think that's valuable information for everyone on the call, just to see where the industry is as a whole. So now let's change tracks to the second section and focus on sustainability. So regardless on which side of the fence you are about climate change, sustainability with efforts to reduce energy consumption and waste can only be a good thing. We mentioned about reducing high heat in the control cabinet by innovative designs, but how can we truly impact the energy use in a process? And why is this even more important today than it has ever been? For some, the 800-pound gorilla in the room is the looming climate catastrophe if we don't do something about general warming of the planet. But for others, due to monetary policy, rise of conflicts around the world, we now have a situation where the energy price, as well as energy availability in some regions, has elevated energy costs to a major concern of all heat treaters. This alone should prioritize attention. But we also have an added driver in the recent SEC proposals for emission reporting. And before we go into some of the details in ways to reduce energy, let's just spend a few minutes unpacking the SEC situation. The core of this is meant to be around providing full disclosure to the investment community of the risk in a business. And depending on your attitude to investing, this might have a direct or indirect impact to everyone's finances. Looking at direct, by adding the transparency of emissions from a large public company, you should be able to understand how it's coping with its overall energy issue, whether you think in terms of climate or just generally how it manages its energy, as this rising energy cost will hit the P&L. On an indirect basis, the majority of us have some form of 401k or pensions or savings. The larger pension companies with their 30-year horizon, so now that's looking past 2050, are wanting to move money to where it's considered a safe return. Their performance has a direct impact on your future finances. So what is SEC emission reporting and what's the current status? Now, I've been keeping a watchful eye this week as there is meant to be an imminent announcement. The rule went out for public comment a while ago and there were some legal challenges and we're just waiting on the latest developments. If it is launched in time, data collection on emissions will start in 2024 and be reported in 2025 for large public companies. And likely that if you are any part of the supply chain in these large corporations, you will have probably been asked to provide your input already, or you will be asked very shortly. Now to note, if you are in the supply chain anywhere around the world, this could impact you on what data you're being asked to provide. So just in sort of a brief way, what is scope reporting? So split into scope 1, 2, and possibly 3 reporting. Some companies are tacking on a scope 4. In emissions, we're talking about GHG or greenhouse gas emissions. So scope 1 emissions are sources that are owned or controlled by the organization. So if you think in our world, this is mainly looking at emissions from manufacturing operations and company vehicles, particularly relevant for commercial or service heat treaters who transport goods to and from their customers. Scope 2 emissions are from purchased energy, electric, steam, heating and cooling that is all consumed by the organization. Scope 3, all emissions across the company's value chain, including upstream, so suppliers, so probably the majority of this audience for some form of thermal process, and downstream related to product use and disposal. So organizations will likely have to report all this information to manage their environmental impact. And this data will be crucial in developing strategies to reduce carbon footprints, comply with regulations, and align with sustainability goals. So now this info is important across all stakeholders, from you and me to investors, customers, and regulatory bodies. What's really interesting is there is now a fourth scope under discussion, scope for avoided emissions. So all the above scopes are based on reporting the current status and obviously putting in actions to improve. But what it doesn't include are the efforts made to reduce potential emissions by strategic considerations. This is where scope 4 comes in and can be used to capture the decisions made to avoid emissions in the future. In our world, this might be decisions around what equipment we buy for our thermal processes, atmosphere or vacuum, gas-fired, low carbon gas, hybrid or electric solutions. This could be a burden to collect and collate the data necessary to comply, added to evolving regulatory standards for heat treat, and you are keeping a team of people just busy on admin. But if we don't start collecting and understanding this data, then the energy costs and emissions will continue either as they are or potentially increase. Deming taught us we need to plan, do, check, act. And without this data, this cycle is not possible. I strongly suggest to all of you that you look at the data platforms available today and discuss with your suppliers how to ultimately collect this data so it doesn't become an unnecessary burden. I think we've got another poll question. Okay, so where are you on your journey to scope reporting? Either never heard of it, just learning, already have a plan, you're already capturing data and providing to customers, you've already got this all sorted and you have an automated data collection and reporting system in place. Okay, let's move on. So very interesting results. So nearly 40% never heard of it, similar amount just learning, and again, sort of 9–10% already have a plan on capturing data, and just a small percentage already have some automated data collecting and reporting. So again, I think useful for the whole industry and audience to understand where we are with this scope reporting concept. Now, let's look at a couple of ways to reduce energy use in a heat treat application. By far, the most impactful is right-sizing your equipment. Hearing from my family back in the UK, so I'm based in Colorado in the US, when household gas and electric prices spiked recently, there was a significant move to small kitchen top efficient air fryer combo ovens. And this small investment was paid back over a few months compared to running a conventional sized oven. So when you're designing or selecting a chamber, autoclave, oven, furnace, kiln, you have to be really conscious of the size of the unit. Second is making sure that you run with an optimum load. This is tough during troubled periods in supply chain, but I suggest you need to work in a transparent way with your customers to hatch a plan how you can meet optimum load size requirements. Third is running batches that create rework. As in the past, right first time quality is key, but now this has an impact on energy use and unnecessary energy costs. Scrap today is usually highlighted and actions put around reducing scrap, but I still see operations routinely spend additional time and energy, especially in tempering operations, to make up for some loss of control in the primary furnace. And a lot of this is not reported. Fourth is data capture. If you don't collect data on your energy use by application, and many still don't, it makes it very difficult to prioritize actions. Either data loggers or invest that little bit extra in advanced SCRs that come with energy counters or metering built in. And finally, fifth, advanced algorithms. We can split this by equipment level and plant level. So if we look on equipment, make use of features such as cutback algorithms to avoid overshoot, as well as PID sets across your temperature range, and use auto-tune to quickly and accurately set these parameters. You would be surprised at how many controllers in the field still run with their default settings. And trust me, this is not tuned to your process. A quick way to check is just to watch your process and see if the controller is in control and the process variable matches the set point. Steady state control. So old rules of thumb of 1 inch soak per 1 inch of section have been applied to atmosphere furnaces for decades. Newer algorithms can start to provide feedback on the core temperature of items being heat treated by analyzing information from PID constants and other inputs without needing a load thermocouple. This virtual load sensor is currently on test and shows encouraging signs of saving energy costs. So looking plant-wide, advanced SCRs have the ability to talk to each other, whether across zones within a furnace or across multiple pieces of heat treating equipment. The PLM, or Predictive Load Management feature, can aid in reducing peak power demands by scheduling power use across devices. The Watlow I4O Technology and Data Insights program captures data at the plant floor level, can be by individual equipment as well, and securely sends this to a cloud server for detailed analysis via AI-enabled data scientists. We've been running a number of trials with this in the US during this last year, and I may be looking for some additional companies to trial early in the new year, so please contact me if this is of particular interest. So the final section that we're going through is on evolving regulatory compliance. We've now seen the AMS 2750 standard is on a 2-year track rather than the previous 5 years. Currently in revision G, and we will soon be talking about H. Also CQI 9 version 5 is in the works. As an industry, we have to be agile to meet these evolving standards, and as a supplier, we have to be in front of any changes. I think there is potential for a different class of temperature sensor in the future, based on some of the specialist work within Watlow, but more to come on that later. And obviously, we'll need to influence the standards to accept changes. We've already seen this open up with RTDs and other types of thermocouples in recent AMS 2750 updates. One of the areas of focus in Watlow is around precision control. Back in AMS 2750D times, for a short time there was a requirement at higher temperatures to be the equivalent of 0.1% accuracy. At Eurotherm, we doubled down on this requirement across a range of products, and we have some improvements with Watlow products coming out early in 2024. One area we also focused on was sustaining accuracy and not just instant accuracy. As part of our internal approval process, we'll put our new designs of devices and functions on test for 3 months to assess both instant as well as sustaining accuracy over a period. What you don't want is drift between calibration periods that move your instrument out of calibration accuracy. Then all the batches that are being processed are potentially suspect, with the requirement to alert your customers to this situation. Now, managing all the compliance tests at a shop floor level can be challenging. And that's why we brought out a special version of our 6000 data recorder called the AeroDAC to aid management of thermocouples, SATs, TUSs, and calibration by providing a status dashboard directly on the furnace. Digital data management standards are going to continue to evolve. The basics are capturing data at source in a secure or tamper-evident format, protecting that data as it goes in transit, and then also protecting the data during its long retention periods. That can be anywhere from 5 to 30 years, depending on the industry and customer. We've also had some feedback over the state of data management solutions in the industry. Words like cumbersome, clunky, not intuitive have been thrown around at some of the major suppliers of this type of equipment. Now, having grown up with Review in my former heat treat plants as a data trending and historian package, I can honestly sympathize with this view. It's okay when you have a dedicated person, time served in the company that can learn these packages and then use them day in and day out. But now with changes in personnel, less experienced heat treaters, shorter employment contracts, there needs to be a better and more intuitive solution. Thankfully, we have a solution for this with the launch of Data Reviewer 5.0. This is a completely new data trend analysis, reporting, and historian package. Moving away from a system designed on a confined database size has removed the need for constant database management that is inherent in the former Review and other packages on the market. Data storage really is now only confined by the storage capacity of the PC hardware. As you can see from the screenshot, the UI has been completely redesigned and has a modern browser-based view. You can view secure linear or circular trends as well as a spreadsheet view. The navigation has been made simpler and a trend chart is only one click away from the record in the database. Batch automatic reporting is now available, along with an imminent release with a connection to our TUS auto reporting software. To avoid the data silos mentioned earlier, the system has a built-in OPC UA option for enabling connection to OPC UA clients on-premise and in the cloud. This is a read-only connection, so cannot affect the data integrity of the raw data that is protected in a tamper-evident file format. The new system also has extensive user security options, and I think this will be an evolving trend in upcoming releases of regulations. I hope the detail in this webinar has been valuable. This is the start of a series of webinars from Watlow, and over the coming months, we will include updates from other vertical industries, as well as more general product updates. We have an expanded capability with the engineering teams across Watlow and Eurotherm, and so I am looking forward to providing you several updates in 2024. So I think we have another poll. Yeah, this is one last poll. Do you have a connected centralized data management system or historian? And just no system at all, system and you download to USB, or all the instrumentations are connected by Ethernet. Okay, let's look at the results. So just over 20% with no system at all, 25% download to USB only, with 50% all instruments connected by Ethernet. Okay, again, interesting results. So that brings us to the end of the formal part of the presentation. I think we have time for a few questions. So let's just take a quick look at the chat. Okay, so we've got one coming in. How do I get started with evaluating a data management solution? So we do have an evaluation version of Data Reviewer on the eurotherm.com website. An alternative is to contact us directly, and we can set up a webinar either through our direct teams or through one of our local channel partners. So please reach out. See if there are any others coming in. Okay. Where can I find out more about thermal loop solutions? So we do have a white paper on the website, and I believe this is also included in the documents section in the webinar, so you should be able to download that directly. This is the first webinar on this topic, and so we'll go into progressively more detail about the different offers in subsequent webinars, probably now next year. Another question, will this webinar be available to watch after this session? Yes, I believe it's been recorded and it'll be available on demand. Okay, another one. You mentioned about I4O and possible pilots in the new year. Who should I contact? So I think my bio details are on the webinar. Alternatively, just direct email me at peter.sherwin@watlow.com, or just go to the bio and pick up my information there. Other questions? What is the timetable of release of Reviewer 5.0? So that's already released. So that's available today. Another question, what is the virtual load sensor technology? So that's currently on test. It's being developed by our R&D teams. And so there will be more on that hopefully next year. Okay, I think that's probably come to the end of the questions so far. So just want to thank everyone for their time today. And also to Paul Schinkel for the production side of the webinar, and Rich Lavens, who's been monitoring the chat and answering questions as we've been going forward. So take care, everyone, everyone in the US, wish them a very happy Thanksgiving for next week, and hopefully we'll see you all soon. Okay, bye-bye.